Hi there, grade 9s. We're going to be going through the gizmo, but instead of just listening to me, we're going to be looking at the video so you can fast forward as the case may be. And I'll be kind of going through some things myself. Now, these first ones we went through, and the key thing is when you have the greater half-life, 35 seconds, it takes longer to decay. And that's pretty simple. Question 4. You just set it, and you do it. So turn that off. So it's annoying. Okay. You just set it. And you just record numbers, and hopefully, what you see, the number approximately divides by 2, but not exactly 2. So maybe you didn't see that. Question 6. You just do the experiment 5 times. And you find an average, and hopefully, I help some of you, and you actually used copy and paste your table into a spreadsheet, and you did it there. Half-life. This is the definition that you need to know, is the amount of time it takes for half of the radioactive particles to decay. For this substance, because you said the 10 seconds, the half-life was 10 seconds, so every 10 seconds, it goes down by half. We're going to be graphing this in our next activity apparatus logger pro skills. And that is the definition because it goes down by half. And then we just, the key thing here is turn on the theoretical. So I'm going to do this here. We set this to 10 seconds. We go start, turn on the graph. And then it tells you to theoretical decay. So right here it has the graph of what it should be. You can see that it matches the graph in here. It didn't. So real life doesn't always match the perfect pattern. Okay. Oh, the theoretical decay. Actually, no, I did that wrong. I didn't follow instructions. I went ahead of myself. Theoretical decay. Okay, and here we'll actually get the perfect values at 10 seconds, 64, at 20 seconds, 32, and so on. So basically, we got the perfect values here, which are different than the values you got with a more random situation. So those are perfect values. That was activity A. Activity A was just basically doing and recording. Activity B, we're measuring and we're thinking a bit more. Okay, how do we find the radioactives? The graph. Isotope A. So I'm going to reset this. I'm going to go back to random. Yeah, that's really loud. Let's turn that down. Those clicks. And we're going to go isotope A. And let's just go. The key thing is we have this graph and it goes from 128 and half, or 128 is 64. That's 80. That's 80. That's 60. This is 70. Halfway 65. So I'm going to say it's about here. This is 25 seconds, maybe around 30 seconds or something. Let's see. And then it has something called a half-life probe. So we can just drag this towards exactly half the number, which is 30. No, I need a 64. It goes from 69. I don't actually get 64. If we go and show theory, can I get the theory? No, it doesn't go in the theory. Such is life. So I don't actually get 64, so I'll go 63, and I'll say 30 seconds. Check the theoretical data selected. See, I gotta read instructions here. I didn't do this so well. Let's reset this. Theoretical delay. Decay. You see, it all comes down to reading the instructions. Now we can get the perfect value, and I need to go 64, which is 31, which is what they got. So the key thing is reading the instructions, including the bolded words. I was wondering about that, to be honest. Collect the data, 1 half-life, 2 half-lives, and so on. So 1 half-life is 31 seconds. And then I need to go down to half of 64 is 32. So I either go down to 32. I get 62 seconds. 3 half-lives is when we're going to have 16. And that's 9. I got 92 seconds. I got 93 because maybe. Let's see here. I got 94. That's close enough. That's fine. And then we need to find 8. So we get 8. I get 123 seconds. I got 124 seconds. And we need to go down to 4. Because half of 8 is 4. 150. They got 155. Maybe things change as I did these answers. I'm not sure. So you find the time. You predict what do you think it should be. And then it's the actual number. No, they wanted us to go to the times because we know the half-life. See, I did this wrong. Again, my goodness, your teacher's not so good, is he? My goodness. So we got to go to the 1 half-life. The time it takes to go to half is 31 seconds. I did it backwards. I had to go to 31 and find out it's 64. Then we go to 62 seconds. And they get 32. Then we go to 93 seconds. My goodness, you're a teacher. And I get 16. And then we go to 4 half-lives, which is equal, so it's in the calculator, 30, I know it's on the paper, but I was going to model this for you. 31 seconds times 4 is 124 seconds. So I need to go 124 seconds. And I get 8. And then equals times 5, 155 seconds. That's 5 half-lives. And we get 4. So that's what we predict, and that's what we measure. Good. Now we need to calculate the percent that's left after each half-life. So how they did this is first there is 100. Then there is 64 left of 128, and that is 50. I'll do some on the calculator for these other ones. Then we had 32 of them out of 128, and we see that is 0.25 or 25%. Then we have, 16? And we get 12.5%. Then we have 8, 6.25%. Then we have 4, 3.125%. I'm assuming the calculator is being recorded. I hope it is. Okay, so suppose you found material that had 12.5% of the original atoms, and the half-life is 47 years old. Well, if it's 12.5%, we know that's 1, 2, 3 half-lives. I'm recording, you may not want to come in. And if it's 47 years old, we just go like this. It's 47 half-lives times 3 half-lives, and we get 141 years old. There we go. Let's keep on going here. Activity B number 6. Use the gizmo to find the activity of isotope B. What is it? Tell us 17 seconds. Let's see if we can get that. So we'll go to isotope B. Now reset. Isotope B. Press start. And we just need to find the half-life. If there's 128 to start, we need to go down to 64, right there. and we get 17 seconds. If you liked other numbers, as a note, if we started at 100 of these, let's do this again. Let's move this other way. That was a spoiler, but it's true. Okay, half of 100 is 50. So if we go to 50, boop, it's still 17 seconds. If we started with, let's say 80 of these, half of 80 would be 40. Guess how long it takes to get the half? I'm betting it's going to be 17 seconds. Let's find out. Let's go to 40. And look, it takes 17 seconds. So the half-life doesn't care about how much you start with, it's as time goes to half. Half of 40 is 20. So it'll be 2 half-lives. So I'm going to guess that's 17 times 2, 34 seconds. Let's find out. 34 seconds. So that's what half-life is. Number 7, practice. Click reset and select the mystery. Let's see if I can do this. The mystery half-life. Crank it back up to 128 again. And this in half-life will be different. Each time you run the simulation, run at least 3 trials. In each trial, measure half-life using the half-life graph. Oh my goodness. Let's just run this baby. It's different every time. So we'll always get a different answer. So half of 128 is 64. I just need to go to 64. I got 55. And what I would do, I take a screenshot of that. Boop, boop. Right click to copy. Copy image. And then I would have pasted that like that. And I would do that 3 times. Let's just do that once more. The first time was 64. Sorry, 64 is 55 seconds. Let's reset. This will show that it's different every single time. Anyways, 64. This one is 68 seconds. Again, I would just take a screenshot and I would do that 3 times, practicing finding the half-life. Using it as whether the number of atoms represent the actual half-life you measure. Oh, I'm a spoiler. I already did that when I did the 50. So I did the 100 and I did the 80. It doesn't change. Extend your thinking. Let's change this. It tells us to go to 100 because then we can do it like we can pretend 100 is 100%. It tells us to set, let's go up here to leisure choose half-life. And I think they said 6 seconds because every 6 seconds we're going to represent 6,000 years. Let's just run this. I should change this graph if I can. Yeah, let's zoom in this graph a bit. Oh yeah, it's much better. So if I want to find 63% of the original carbon-14 atoms, I just need to go 63. What's happening here? It's already showing me a half-life. Oh, that's so cool! Okay. But anyways, I don't want 63 though. I don't want to find the half-life. I want to find 63% is times 4,000 years. 22%. I need to go down to 22. 22. 13 seconds. That should be 13,000 years. 79%. All right, there, 79% is 2,000 years. with 3%. Oh, let me do zoom out now. Oh. Where am I? And they have a range there because both 30 and 31 are 3, so that's 30 to 31,000 years, and that's how they got those numbers there. That's completely fine. Hopefully you got it, or if not, hopefully this helped.